The third lesson is about the interaction of various types of radiation with matter. The smallest particle matter is an atom. The atom of any chemical element is a complex system that can be divided into elementary particles. The nucleus of an atom consists of two building blocks, protons and neutrons. Both of these particles are mutually divisible, so they have a common name, nucleons. When excited, a proton can become a neutron, and a neutron can be converted into a proton. Electron and proton are charged particles. The amount of charge in each of them is exactly the same, but the charges differ in sign, with the proton always having a positive charge and the electron negative. The neutron is the only component of the atomic nucleus that does not carry an electric charge. Due to its electrical neutrality, which is evident from its name, the neutron has the highest penetrating power of all particles in nature. Neutrons have no electrical charge. Conventionally, neutrons, depending on the kinetic energy, are divided into fast, superfast, intermediate, slow, and thermal. Neutron radiation has a high penetrating power. Slow and thermal neutrons enter into nuclear reactions. As a result, stable or radioactive isotopes can be formed. Neutron radiation is a flux of neutral, that is, uncharged particles of neutrons, which are an integral part of all nuclei with the exception of the hydrogen atom. They have no charges, therefore they themselves do not have an ionizing effect. However, a very significant ionizing effect occurs due to the interaction of neutrons with the nuclei of the irradiated substance. It is known that radioactive radiation interacting with the irradiated medium forms electric charges of different signs. This process is called ionization and is due to the action of the irradiated medium of the nuclei of helium atoms, alpha particles, electrons, positrons, p particles, charged and uncharged particles, corpuscular and neutron radiation, electromagnetic, gamma radiation, photon, characteristic, Bremsstrahlung, and X-ray and other radiation. None of these types of radioactive radiation is perceived by the human senses. Each element has its own serial number, which determines its position in the table of Mendeleev. The number of protons in the nucleus is numerically equal to the atomic number of the element. The total number of protons and neutrons in the nucleus is called the mass number of the element. On the atomic scale, both protons and neutrons have a mass of one atomic unit. For example, a hydrogen atom whose nucleus consists of only one proton has an atomic mass equal to 1. A helium atom with a nucleus of 2 protons and 2 neutrons has an atomic mass of 4. The mass of twin or isotope of hydrogen called helium-hydrogen or deuterium with a nucleus of 1 proton and 1 neutron is equal to 2, and the atomic mass of tritium, the third type of hydrogen, the nucleus of which consists of 1 proton and 2 neutrons, is equal to 3. Thus, an isotope is a kind of the same element with the same number of protons in the nucleus, but with a different number of neutrons. The phenomenon of radioactivity consists in the fact that the nuclei of radioactive elements have the ability to spontaneously decay. The most important products of radioactive decay are alpha and beta particles and gamma rays. Alpha radiation is a stream of helium nuclei. The positive charge of the alpha particle is 2 units and the mass is 4 atomic mass units. The alpha particles emitted by radioactive decay have energies ranging from 4 to 10. In air, the range of an alpha particle range from 3 cm to 11 cm. In biological tissues, from 31 microns to 130 microns. The characteristic result of the interaction of alpha radiation with matter is ionization. Alpha particles have a tremendous ionizing power. In air on a path of 1 mm, alpha particles create on average about 3,000 pairs of ions. The penetrating ability of an alpha particle in biological tissues is insignificant, and the thickness of the surface layer of the skin is quite sufficient for protection from external flows of alpha particles. However, it is extremely dangerous for alpha-active substance to enter the human body with concentration of more than the maximum permissible values. Beta particles are electrons, negatively charged, or positrons, positively charged, emitted from a radioactive nucleus. Beta particles have a charge of -1 or +1 charge. In air, the path of a beta particle varies within wide limits from 0.13 centimeters to tens of meters. In biological tissues, from 0.002 to 123 millimeters. Gamma rays are electromagnetic radiation generated by energetic changes within the core. The energy of gamma rays for various isotopes is approximately in the range from 0.01 to 10 MeV. The propagation speed of gamma radiation reaches 300,000 kilometers in second. Gamma rays passing through any medium interact with electrons and nuclei that make up the observing substance. Low-energy gamma quanta can interact with matter through direct collision between the gamma quantum and one of the electrons of the atomic shell. An electron that is knocked out of an atom as a result of this interaction is called a photoelectron. In photoelectric processes, a gamma quantum, as a result of this, cannot interact with a free electron, because under these conditions, the law of conservation of energy and angular momentum is not fulfilled. Unlike the photoelectric processes, which occurs only on bound electrons, the Kapton scattering process can occur on free or weakly bound electrons. When the energy of the gamma quantum is larger, the gamma quantum can interact with the nucleus. In this case, the gamma quantum ceases to exist and two electrons appear positive and negative. Due to the equality of the masses of the positron and the electron, the most probable distribution of energy between them is when the energies are equal to each other, but electrons and positrons with different energies can also arise. The resulting electrons and positrons lose the energy to ionize the atom of the substance. The second lesson is over. Thank you. Bye.